The lectures this week are basically walkthroughs of how to use the statistical program SPSS to complete various things that we've been talking about in class. I've gone a little above and beyond what we've actually been doing in class to kind of give you also a intro to using SPSS. I would strongly suggest that you download all of these videos, have them available for other classes, and also to make them quickly available for you as you complete various homeworks and assignments and to help you understand better what we've been talking about in class. So a lot of times, a lot of the things that I've been mentioning in the lectures in the last 4 weeks, we're also going to talk about how you'd actually do those in SPSS this week. So this particular slide deck is going to be looking at how we clean data, how we reverse code something if we want, how we look at internal consistency and calculate that and interpret it, and also how we could compute a variable from existing variables. All of things that are very important to do in SPSS and are important about preparing a data set potentially before we actually start looking at it in more detail. So for cleaning data, we're basically looking to find out if, statistically speaking, there's anything in the data that doesn't make a lot of sense. Now, a lot of times, a lot of our data sources are now coming from online places that are calculating the data for us, but you may actually still be using paper and pencil surveys. You may be entering the data into an SPSS, or you may be cutting and pasting, and mistakes can occur. So we want to make sure those mistakes aren't there. So when we're looking at cleaning data, we're going to start with, again, the data set that we have. Whatever data that is, and that can include condition, that can include surveys or assessments, that can include demographic information. And we're going to go analyze descriptive statistics frequencies. And this is going to be very similar to what we're going to be doing in one of the other slide decks where we're actually looking at descriptive statistics. But in this case, we're looking at it for a very specific purpose. Once we're there, we're probably going to click on all of our variables. We can hit Control A, basically select all our variables on the left-hand side, click the arrow and bring them all over to the window on the right-hand side. That's going to allow us to basically look at all of the data with this technique. If there's specific variables or you simply want to, you can just click on each variable, hit the arrow, and bring them over that way as well. Once all your variables are on the right-hand screen in that block, you can hit Statistics. In statistics, we're going to select mean and standard deviation. Again, notice there are more options here. If you were actually wanting to examine skewness and kurtosis, and you were in a class that was asking that of you, that's how you'd get the data here. If you also wanted to look at mean, median, you could look at that. You can also do some. And you may actually want to click on mean, median, and mode, because that's also going to give you some information about whether the data is normally distributed. Remember, normal distributed data is continuous data. In other words, it's inappropriate to look at this if it's categorical or bivariate. Bivariate simply means two-level data. But assuming that it's actually numerical, sequential, and effectively we're expecting it to be normally distributed, if we selected mean, median, and mode, it would actually tell us a little bit, because if those numbers are very similar, it probably means it's symmetrical. If those numbers are not, it probably indicates there's a problem. But in this case, we're simply going to look at mean and standard deviation and click Continue. And then we're going to click OK. So that's going to give us data on every one of these variables. So for every one of the variables, they're going to appear in this chart. We're going to basically see how many valid number people were on each variable. So we have condition, heterosexuality, 2 different forms, actually 4 different forms, age, school year, demographics. And it's going to show us how many people responded. Notice that 52 people filled out the survey, but only 50 actually provided their age. So 2 people didn't give age in this case. So there was 2 missing. That lets us know that there's 2 people that are missing. Now, if we actually knew for a fact that all 52 provided age, we might want to look at the 2 that are missing and look up their original forms and see what happened. We're also going to get our means and our standard deviations. Again, I want to stress that mean and standard deviation is an appropriate descriptive statistic for continuous data. So for example, heterosexuality 2.5 or 2R, 3, and 4R all are appropriate. So is age, and so is school year. So we can look at all of those because all of those are going to be on some form of numerical spectrum, 1 to 5, 1 to 4, 1 to 102, and the approximate difference between each is equal. So the difference between someone that is 5 and 6 is the same as the difference between someone that's 50 and 51. And likewise, school year, 1st, 2nd, 3rd, or 4th is going to be fairly similar as well. So we can tell by looking at school year, for example, the mean is 1.69. That basically tells us that most people were probably sophomores in this case. with a standard deviation of 0.94. So most people were either ones, twos, or threes. There were very few seniors in this sample and example. However, condition is simply what condition they were in, and there was three conditions, 1, 2, and 3. So the mean here, considering the condition, those numbers, 1, 2, and 3, they're not equal distance, and they could have easily been 3, 2, 1. They simply represent categories. Therefore, the mean and standard deviation are inappropriate. We wouldn't be looking at it. And we need to make that distinction, not the data. The data is going to run no matter what we ask it of it. No matter what kind of data we put in, SPSS is going to look at it mathematically and create these values for us. It's up to us to know, is it appropriate to look at those values? We're also going to get a chart for each and every one of the variables. So for example, in this case, we have a 1 to 5 scale. We look at the first one, heterosex 3. We see 2, 3, 4, 4, and 5. So no one responded 1 on this scale. And in this case, high numbers mean actually less sexism. So no one reported being extremely sexist, but 11% were willing to admit that they were somewhat sexist on this particular scale. Now, again, knowing it's a 1 to 5 scale, we'd not necessarily see anything wrong here. We wouldn't assume there's any problems, though I might want to double check the data to make sure there were no ones. On heterosexual 4R, which is basically a reverse score item, we can see that, again, we have 1, 2, 3, 4, and 5. So there were 11.5% that were willing to admit a 1 on this scale, but we also have a 9 in there. There shouldn't be any 9s. It's a 1 to 5 scale. So I'd want to go back and take a look and notice the frequency is 1. So there is 1 9 in there. That's probably a miskey. I'd want to see what participant it was and take a look at their original forms and see what their actual score was. And I'd want to correct it. That's what we're doing. We're cleaning the data. Again, we'd go back to our original scale, we'd take a look at that particular item, we'd scroll down, and we'd find actually that participant 11 is where that 9 is. So I'd look up the original participant and also take a look to see what their actual score was. It was probably miskeyed or misentered. Notice also that if we look at age here, we actually have one of those missing factors. So participant 10 did not provide an age. I might go ahead and take another quick look at the forms and look at number 10 and make sure they left that one blank, to make sure it wasn't just missed as someone was entering the data. So you notice that one of those charts was reverse coded. So sometimes we actually set up a scale to where it is reverse coded. In other words, the way people respond to it is reverse coding. But one of the ways we often will actually create a series of items is we may have a reverse coded item built in. So think about extroversion. So I might have an item that says, I like to be the life of at a party. 1 strongly disagreed, and 5 strongly agree. So someone that was very extroverted, likes to be the center of a party, center of attention at a party, would probably respond to 4 or 5. So higher numbers mean more extroversion. But I might have an item that says, I prefer to stay in the background at parties. 1 strongly disagree to 5 strongly agree. In that case, it could still be measuring extroversion, but it's now measuring it in a reverse direction. So now 1 represents extroversion and 5 represents not being extroverted. Now, if I'm wanting to actually collapse all those items into a final score, I've got a problem. That item is actually needing to be reverse coded. So what we do with reverse coding is we first note within the actual measure itself what items need to be reversed. In other words, what items are measuring the construct but measuring it in the opposite direction of the other items. We are then going to go to transform, recode into a different variable. Once there, we're going to select the variable that we want to recode. We're going to hit the arrow and we're going to bring it over. Notice we could do this with more than one variable if they're all on the same scale and they all need reversed in the same way. We're now going to give each variable a new name. So for example, what I usually do is I will call it, this is heterosexuality 1. It needs to be reverse coded. I'm going to call it heterosexuality 1 reverse. Notice that SPSS does not allow special characters or spaces. So you basically just need to do all into one letter-based name. So once I actually have that brought over, I'm going to click change, and that's going to change it on that variable. And again, if I'm doing multiple variables, I'll have to do this for every single one. Once we've actually done that, we have all the variables we want to reverse code in the middle box. We've brought them over from the left. We've renamed every single one of them and click change. We're now going to click old and new values. That's going to bring us to this chart. And we're literally going to have to just propagate what the change is going to be. We're going to put the original value in on the left. We're going to put the new value on the right, and we're then going to click enter recoded value. So that's going to be happening for every single value we have. So in this case, it's a 1 to 5 scale, and I'm changing it to a 5 to 1 scale. So 1 equals 5, 2 equals 4, 3 equals 3, 4 equals 2, and 5 equals 1. I'm going to do this 5 times until we repeat, and all the recoded variables are now listed in the old to new box there in the middle right. Once we've done this, we're going to hit continue. Once we're here, we're going to hit OK, and we're going to find that in our original data set, a new variable has been propagated. Notice there is the option when we were looking at this on the first screen on reverse coding to actually code into the original variable. So we could just reverse code it. I tend to like to create new variables. That way I've got the raw data if I ever need to go back. But I do want to make sure that whenever I'm doing any additional examination of this scale, that I use the reverse coded items, not the original items in the data set. So if we want to look at internal consistency, I've been talking about internal consistency of a way to look at a multiple item scale or test or assessment that has multiple items that we're wanting to make sure that they're all measuring the same construct. So in this case, I'm going to have my data set that I've already cleaned, and I've already reverse coded any items that logically need to be coded in a different direction to make sure they're measuring the same construct in the same direction. In other words, high scores represent high levels of that construct, low scores represent low levels of that construct, or vice versa. We just want to make sure that they're all in the same direction. We're going to again select Analyze, Scale, Reliability Analysis. That's going to bring us to this table. Again, we're going to have to bring our variables over. So we're going to select every variable that's in our scale, make special care to only bring over the reverse coded items if you did any. So if there's still a heterosexual 2 and a heterosexual 2R, you're going to select the R version, not the 2 version, not the original version, the one that's been reverse coded. Once you have clicked all your variables, and you can click Shift down to click multiple variables, or you can simply bring them over one at a time. You're going to click the arrow each time, and you're going to click Statistics. Once we're in the statistical window, we want to make sure that we click Scale if item deleted. This is going to give us valuable information of what happens to the actual internal consistency value if we pull out items. A NOVA table is going to usually have none selected, and that's fine. Again, there's a lot more things we can look at, including covariances, means, correlations. We can do actual additional tests, but in this case, all we're interested in is the Combrax alpha for this purpose. So once we've done scale if item deleted, we're going to hit continue. Now we have everything in the SPSS commands that we need. We're going to hit OK, and we're going to get this information. So first, we're going to get a scale of all variables. That's basically just going to tell us what was included, how many were excluded, and what the total number was of people that were in this sample. And we're going to get that Combrax alpha, the reliability statistic. In this case, it's 0.727, or rounded up to 0.73, across 4 items. So there were 4 items in this particular measure, and it had an alpha of 0.73, which is acceptable. Not good or excellent, but acceptable. And again, we're also going to get an individual table showing each item. And it's going to show the scale mean if the item is deleted, the scale variance if the item is deleted, the corrected item total correlation, so how well it correlates with other items, and finally, what the Combrax alpha is if the item is deleted. So notice, for example, if we removed heterosexual 1, the scale would actually get much worse. If we removed heterosexual 3, the scale would get much worse. But if we removed item heterosexual 4R, the scale gets slightly worse. It goes from 0.727 to 0.726. But if we remove item 3, heterosexual 2R, the item does get a little better. It goes from 0.727 or 0.73 to 0.74. So it gets 1.01% better. Whether we would do this or not, in this case, this would probably, again, it's a little bit of an art. I would take a look at that item. If I feel strong that that item does add, it makes sense, it's a good item, it's measuring heterosexism in a good way, I might leave it in. If I was like, it actually will make the scale slightly better, and looking at the item, it's not a great item, I'd probably remove it at that point. But again, that's a call that you would defend as you're talking about how your scale was created. If we need to compute a variable, in other words, so now we know we've got 4 items. They are internally consistent. We decide to keep those 4 items, but we don't want to keep them as 4 separate items. We want to create an average of those 4 items. we're going to compute a variable. In this case, we're going to, again, we're already in our data set. We're going to select transform compute variable. In here, we're going to name the variable. So for example, we might call this total sexism. So we're going to basically create the mean average of those 4 items. We're now going to type in the numerical expression the word mean, all in capitals, with the parentheses. We're then going to select a variable, click the arrow and bring it over, and then we're going to type a comma. And we're going to do that for every variable that we're actually wanting to be in the total of sexism, the mean of the sexism score. When we're done, after we've added all these items, we're going to close that parentheses. So again, at the end of this, we're going to have mean, parentheses, heterosexual 1, comma, heterosexual 2R, comma, heterosexual 3, comma, heterosexual 4R, closed parentheses. Make sure you have a comma between each variable and make sure you close the parentheses. If you wanted to simply add up the variables, you could use sum instead of mean, SUM, and the same variables. And again, this is an example specifically of my data set. Your variables may have very different names, but the concept is the same. So when we're adding up scores, we're going to use sum instead of mean, but in this case, I simply want a mean score. So once I've done that, I'm going to go ahead and click OK, and it's going to create a new variable. That variable is going to end up at the end of my variable list, and it's going to be that name, total sexism. So this is actually the variable I would use. In my case, I'd probably call it total sexism alpha, and I'd put the alpha in just as a quick reminder. In this case, if you'll remember right, it was 0.727, so 0.73. So I'd probably call this total sexism alpha 0.73 or alpha 73. Just as a quick reminder so I don't have to look further to remember what the actual reliance is. Remember when we were talking about the various techniques that we hand calculate, one of the things we often need is the alpha to be able to do those hand calculations very quickly. So hopefully that gives you some information. If you look at all 3 of these SPSS files, you're going to get a general feel of how to do everything we've talked about so far in this class using this particular computer program. Obviously, there are other computer programs out there, R, Excel, all of them allow you to do very similar things. The reason I like SPSS is it's the statistical package for the psychological sciences. That's what SPSS stands for, statistical package for the social sciences. So it's designed for psychology, it's designed for psychological science. It's often used in academia and grad school. It also is fairly user-friendly in how you actually can interact with your data sets.